Periodic motion question 3. So here we have a dust particle at position D on a rotating vinyl disc. A combination of electrostatic and frictional forces act on the dust particle and enable it to stay in this position. I have marked in my diagram the radius here of 0.125 meters from the centre of the disc, and we are told the disc rotates at 45 revolutions per minute. Calculate the linear speed. You can do this straightforwardly using the equation V equals omega r, where omega equals 2 pi f. In that case, you substitute 0.125 for the radius, and for the frequency you just need to be a bit careful here. You had 45 revolutions per minute, so to express that in hertz, that would be 45 revolutions in 60 seconds. So just be careful to match your units. That leads to an answer of 0.59 meters per second. Alternatively, you can think of the linear speed as the dust particles move round in a circle as the circumference 2 pi r divided by the time period, and this would give you the same answer. Next, you're asked to mark on the diagram an arrow to show the direction of the resultant horizontal force on the dust particle. If the dust particle is moving in a circle, there must be a centripetal force. That force will act from the dust particle towards the centre of the circle, so that is shown by the green arrow that I have drawn. Next, you are asked to calculate the centripetal acceleration. You have a choice of two equations for this, but you have just worked out the linear velocity, so it's very convenient to carry on and use acceleration equals v squared divided by r. This leads to an answer of 2.78 meters per second. You could use the alternative expression of acceleration equals omega squared r. Finally, an explaining part of the question. So looking at the disc, it is said that more dust is concentrated on the inner part of the disc rather than the outer part, and you need to suggest why. So the key concept here is the difference in radius of a circular path that the dust would follow. So at larger radii, the particles will need a greater centripetal force in order to follow that path. The second point is to justify why that is the case. Well, at a larger radius, the linear velocity will be greater and the acceleration will also be greater, therefore a greater force. So the key point is that the linear velocity is proportional to the radius. Finally, why is this relevant? Well, there is a limit to how large the friction and electrostatic forces can be in this context, and if the velocity is too great, the required centripetal force will be greater than what can be provided by friction and electrostatic forces. So those are your three marking points to match this question.